In this brief video, I'm going to talk about some of the important units we use for pressure. So yesterday I was talking about atmospheric pressure, and that is a result of all of the gas particles that are pushing down on us, that gravity's pulling down toward the Earth. And it turns out if you're at sea level and you're feeling, in a sense, the full weight of the atmosphere, the full pressure of the atmosphere. I mentioned that is about 14.7 psi, and that stands for pounds per square inch. And we use psi a lot in the United States, but it's not the SI unit, and it's not even the most important unit you need to know for this class. When you're at sea level and you're feeling the full weight of the atmosphere, I'll put that in quotes. You're not really feeling the full weight. That would be tremendously heavy, but you're feeling the full pressure of all of the atmosphere pushing down on you. 14.7 psi, approximately. We call that 1 atmosphere. So the atmosphere, of course you know what that is, but the word atmosphere is also a unit for pressure. So 1 atmosphere, 1 ATM, is about 14.7 psi. Okay. There are other units you should know about for pressure. The SI unit is something called the Pascal. And the Pascal is a really small unit of pressure, actually. It's a small amount. It's derived from the definition of 1 Newton. And if you have 1 Newton, I described what that was yesterday. That's if you have a kilogram that's being accelerated, so 1 kg that's being accelerated at 1 meter per second squared. And if you spread out that Newton, that force, over 1 square meter, so a square meter is a pretty big amount of area. So you have a small force spread out over a really, really large area, relatively speaking. Ends up being a pretty small amount of pressure, but that pressure is called the Pascal. This is called the Pascal, and that's named after a famous French intellectual named Blaise Pascal, who made a lot of contributions to mathematics and also to philosophy. But the Pascal, like I said, is a really small unit, and it takes 101,325 pascals to get 1 atmosphere of pressure. And since it's such a small unit, we normally go with kilopascals, so we don't have to write out all those digits. And so that's 101.325 kilopascals. Okay, so those are the SI units. I guess the Pascal's the base unit, and these are all the international system units there. Another important unit to know about, which one am I not thinking of currently? We've got pascals, PSI, atmospheres. I might have to look at the PDF because my mind has drawn a blank here. What is that other unit of pressure? There, I have to pull up that document. You guys will be looking at this in just a moment. Of course, millimeters of mercury. Okay, so this is probably, in fact, the most important unit you need to know about. There is a unit called millimeters of mercury. And 1 atmosphere is 760 millimeters of mercury. That seems like a strange unit. It's a length of mercury for measuring pressure. But this was the unit that comes from the device we talked about yesterday called the barometer. Okay, the barometer, which was invented by Torricelli, he used some mercury and he filled a tube with mercury, flipped it upside down, and he saw that the mercury would drain out and it would stop at the same spot every time. And at sea level, it would drain out and stop at a height of 760 millimeters. So it's not really a length, it's a height. It's a height of a column of mercury. It's the amount of mercury that the atmosphere at sea level can support. Okay, and it doesn't matter the diameter or really the volume of mercury. All that really matters, turns out, is the height of the mercury. So it could be a really, really thin barometer or a really, really wide barometer. Doesn't matter. The atmosphere can always support a height of 760 millimeters of that substance, mercury, which is about 30 inches, pretty close to 30 inches. And so that's a super important unit for pressure. It comes from the barometer. And in honor of the inventor of the barometer, millimeters of mercury has another name. It's called torr. So 760, rewrite that, 760 torr is the same thing. Torr for Torricelli, the inventor of the barometer, from which we get this unit of pressure. Okay, so let's go back and have a look at this page with some pressure conversions, and we can go ahead and start working through some of those. And I think I will post that page in here. And so let's see. I've actually got it saved in my documents, and so downloads, pressure unit conversions, and I can put that back into the OneNote. So wow, there it is. Okay, so let's have a look at a couple of these, and then I'll let you get to it on your own. Okay, the pressure is recorded as 738 millimeters of mercury. Convert this pressure to atmospheres. So let's do number one together. We have 738 millimeters of mercury. And what we need is an equivalence that links millimeters of mercury to atmospheres. And we have that equivalence right here. 1 atmosphere is 760 millimeters of mercury. This is actually good to 4 significant figures, by the way. Anyway, so we put millimeters of mercury down here and atmospheres up here. And 1 atmosphere is 760 millimeters of mercury. So this is a one-step conversion because we have an equivalence. 1 atmosphere equals 760 millimeters of mercury. So one equivalence, one-step conversion, 738 divided by 760. Okay, and so right about 0.971 atmospheres. That's about as easy as that could possibly be. One-step problem. Just going to make that blue. Keep it consistent. All right, let's do one that's a little bit more complicated. How many pneumatic tools? Many pneumatic tools operate at an air pressure of 90 psi. What's the equivalent pressure in kilopascals? So psi, if you look up here, I don't see psi equals any type of kilopascals, but 14.7 psi is 1 atmosphere, and 1 atmosphere is 101.3 kilopascals. So 2 conversions two-step problem, jumping down to number 6 here. All right, so we've got 90 psi, and for the sake of this problem, let's say that this has two significant figures, 90 psi. I'm putting in a decimal just so we can carry through some extra significant figures. You're not allowed to do that, but since I'm providing this document, let's just pretend it said 90 psi. Okay, so two-step problem, we can go from psi to atmospheres. Okay, 14.7 psi. Is 1 atmosphere. Okay, so that's the first step. And then atmospheres to kilopascals. 1 atmosphere is 101.3 kilopascals. So 1 atmosphere down here, 101.3 kPa up here. All of our units are set up so that they divide out, leaving behind the unit we want. And each conversion factor is valid. The numerator equals the denominator in each conversion factor. So it's set up fine. 90 divided by 14.7 times 101.3. And so it's about 620 kilopascals. Okay, we've used two conversion factors here. This one comes from the fact that 1 atmosphere is 14.7 psi, and this one is coming from the fact that 1 atmosphere is also 101.3 kilopascals. That's a little less precise than the way I wrote it up here, but it's still essentially the same value. They've rounded it to 101.3 kilopascals per atmosphere. So go ahead and continue with the problems I've specified in your lesson plan document, and continue with the midweek assessment on Portal after that.